If you wrote a shell script that does something for you instead of you clicking some buttons or even executing individual commands, then you use the infrastructure as code.
This is DevOps Paradox, episode number 254. What is infrastructure as code in DevOps? Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darin and Viktor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darin reading this text and feeling embarrassed that Viktor made me do it. Here are your hosts, Darin Pope and Viktor Farsic. When we first start out working in infrastructure, I have a bad feeling that we typically just go around and point and click. Was that your first experience as well, Viktor?
Yes, that's always my first, and that keeps being my first experience when I'm faced with something that I haven't used before.
But eventually, we want to move to some sort of as code for our infrastructure, right?
Because I have better things to do than clicking.
Is that true?
Yes. I can watch Netflix instead of clicking buttons in a console.
Oh, okay. Well,
that's better
a good
thing
use
to do, right?
Yeah, I understand. Where does infrastructure as code fall into DevOps?
Before I answer that, I will use the term infrastructure as code right now in a broader sense than people usually do, right? To encompass all the different names that we had throughout history, right? And where it falls, it's very easy. It's the only way we know today to automate creating stuff. Doesn't matter. Actually, when I speak about infrastructure as code, and I'm going to be even broader than that. I'm going to say managing resources of any kind, right? Because I don't know whether Google Cloud Run falls into infrastructure, or is it application, or is it service, or what it is, right? But yes, managing resources as code, the only way we can do it efficiently. The alternative is to click buttons, and I cannot be available 24/7 to click buttons for other people. And other people don't want me to click buttons, and I cannot guarantee that I'm going to click the same buttons and fill in the same fields and choose the same items in a list and so on and so forth, right? So it's the only way to do it. And we know that for decades now, right? If you ever brought, I don't know, Darin, 30 years ago, right? If you wrote a shell script that does something for you instead of you clicking some buttons or even executing individual commands, then you use the infrastructure as code. Hopefully 30 years ago, not today, right? But yes, there is no doubt that we should be able to execute processes that will do something for us, and those processes are defined as code.
Why would I not still use a shell script today?
I'm not necessarily saying that you shouldn't use shell script, right? If your alternative to shell script is clicking buttons, then please use shell script, right? So if the question is, should you use something as code, including shell script or not? The answer is yes, use shell script. Now, within, I'm going to define the management of my resources as code. Shell script is the worst option simply because it's too difficult to write it. You might be thinking, oh, how hard it is for me to create a shell script that will create this something. And it's not hard at all. Hey, you can use CURL in shell script to do that. Easy. Or AWS CLI or whatever you're using. That's fine. The problem is, what happens after you create that something? What happens when you want to update certain aspect of that something? And that's where shell scripts fail, because that would mean that your shell script wouldn't be, hey, create this database. No, it would be, hey, This is what it should be there. Let me check whether it exists or it doesn't. If it doesn't, create it. If it does, then go and check each of the parameters of that something, figure out what changed, and update only that specific aspect of that something, right? That would be a lot of if-else statements in a shell script. A lot. So what is really difficult, it's not difficult, but difficult with shell script, is to compare the states of what you want and what you have, and then instruct the API on the other end to modify only the parts that are different. That's the tough part. And that's where shell scripts fail. It would be too many if-else statements.
What you're referring to, and you said it, what is the state? So what is the state that I've defined versus the state of reality?
Exactly. And that can be many. Variations are infinite, right? The differences in your states.
Now, Terraform managed that through a state file.
Yes, I feel that we as industry go back and forward between using a state file and not. I believe, and I might be wrong, that Ansible, for example, did not use a state file, does not use a state file. I might be wrong over there, right?
No, you're correct. You are correct.
So it's really, as far as state file is concerned, the question is, do you want to trust the state that you keep internally as the current state of something, and then compare that, I'm going to say local state. It's not really local. It can be in some remote place, but local state, and compare it with the desired state. Can you assume that the local state is the actual state, right? And then we have Ansible approach, and I'm half guessing now because I haven't used it in a while, that says, no, I'm going to go to that place, discover the state, then compare it with what you want. And if there is a difference, I'm going to go again back to that API and do something to converge those states. Both approaches have pros and cons, right? The negative thing about local state is that, well, there is no real guarantee that it is the actual state. The negative thing with not having the state is that you have to do a lot of extra work, and sometimes it's impossible to do it. Sometimes you cannot not have state in some form or another. Here's an example. Let's say you want to create a VPC in AWS, right? And through some tool, doesn't matter what you're using, right? And that VPC is created. Now, unlike some other resources in AWS, you cannot define yourself a unique identifier for that VPC. You cannot say it's going to be ID 12345. You cannot say that. You say, create this VPC and AWS assigns it a unique ID. That unique ID is state or part of the state of that VPC, right? It's not the full state, but it's part of the state. And if you don't have it stored somewhere, you will not be able to identify that VPC, and hence you will not be able to figure out what is the actual state of it. So there's full state idea, there is no state, and then there is, I need some state. And I think that no state is very, very difficult, close to impossible. And full state is risky, to say the least.
If people are starting today just dipping their toe into infrastructure as code, and yes, it's 2024, and yes, those type of people still do exist.
Mm-hmm.
Now, in full transparency, you work with the Cross-Plane project.
That's my thing, yes.
That's your thing. But if they are not in Kubernetes yet today,
mm-hmm.
where should a person start learning about infrastructure as code?
If you're not comfortable with Kubernetes, I can tell you that that's not Crossplane. I should probably recommend Crossplane to everybody. That's not the case. Don't even think about Crossplane if you... Actually, there are two cases where I would say don't go Crossplane. First is if you're not very comfortable with Kubernetes, because it follows Kubernetes logic. It makes assumptions that you know Kubernetes, right? And it doesn't really tell you how to retrieve events from something because you know that it's Kubernetes, right? And the second reason is scale. If you're managing one or two databases or one small cluster or something like that, it's an overkill, right? It's not designed for tiny systems. So going back to your question, if somebody's just starting with infrastructure, and especially that something is not comfortable with Kubernetes, then I would say Terraform or Pulumi, right? Depends on whether you prefer declarative format or imperative like Go or JavaScript or whatever you're using. And I believe that Pulumi can now use YAML as well. So one of those two, Pulumi or Terraform. Don't use Crossplane.
In that case. Right.
In that case. No, I'm not saying that. Exactly.
And we will say, what is the correct open source name for Terraform now? Is it OpenTofu, I believe?
OpenTofu.
Right. We'll just leave that there.
I can tell you the meaning of the acronym, my interpretation of it, but then I promise that I will not swear.
Exactly. And that's why we're moving on. So those are in today's world, the Terraform-like items or the Pulumi-like items. And let's stay there for a second. The declarative versus the imperative, or the declarative, meaning here's my YAML, go process it, figure out the stuff, or here's my code, process my code and go do the thing. You tend to land on the declarative side. I'm somewhere in the middle.
I'm actually in the middle as well, but I might be in the middle for different reasons. So let me explain it this way. I believe that the desired state should be stored in a declarative format. And the reason for that is simple. I dare anybody to go to Git repo. Let's say that we find a person now, and we tell that person, here's a Git repo. Here's the definition of how something should look like. Can you understand what that state is supposed to be? Nothing beats declarative format for that, right? If I need to go through Go and then, so there is this function that calls that function that calls this function, and it would be close to impossible for me to assemble in my head what you want it to do. What are supposed to be the exact parameters of something. Now, that being said, I'm not saying that you should write them in declarative format. I'm saying that you should end up having them in declarative format in Git so that anybody can easily deduce what that something is. Now, how you get to it is a different question. Like, when I write, let's forget infrastructure for a second, right? When I write Kubernetes manifests, I have some cases that are relatively simple. Let's say up to 100 lines of YAML. And for that, I use customize. I don't use, because that's the simplest way. That's as declarative as it can get beyond writing pure YAML, right? But when I go further, when I have more complex things, as I often do, I personally use Q, right? That doesn't matter now by Q, right? It could be Go, it could be JSONet, it could be something else. Doesn't matter. Actually, JSONet would be still declarative. Anyways, I use Q, but I output that Q. I use Q to define all the logic, everything. I output it to YAML, and then I apply it to the cluster. So I do both, if that makes sense, right? Because, and here's the thing, and I'm going to stick with Kubernetes now. I think that it applies to everything. On one end, there is something the way you define. Let's say Go, doesn't matter. On the other end, there is API that you want to talk to. And Kubernetes API accepts only and exclusively YAML. Now I have two options there. I can say, I'm going to write it in Go, and I cannot I cannot send Go instructions to Kubernetes API. You cannot do that. What you can do is have a process that will convert that Go into YAML and set it to Kubernetes API. Helm does that. Every tool does that. Now the question is, do you want that tool to convert Go in the background and send it to Kubernetes API, or do you want to have a process that will convert it into YAML first, store it in Git, and then send it to API? And I opt for the second way, right? It's not harder for me because all those tools have the option to output to YAML. It's just one extra command in my pipeline.
Well, you're trying to get to the point of an effective YAML. Just like in Maven, you can create an effective POM, even though the actual POMs you're looking at, you may have parent POMs, you might have all these other things, but you can run it to say, okay, give me the effective. Like, let me see the whole thing.
I wasn't aware of that. Now I am. And that's what I mean. Exactly. And I'm guessing now, because I'm not that familiar with Maven anymore, you can just as well apply or execute that effective XML, right?
The effective POM is what's going to be processed.
Yeah, there we go. That's what I would store in Git.
But that would scare me by storing that in Git. Why? Well, what happens when somebody goes in and makes manual changes to that final file? When they shouldn't be, right? Because you've written everything in Q, and Q is supposed to be generating this file. And now you're doing manual things to the file? That seems like all sorts of trouble is getting ready to happen.
If that same person changes my queue, would that be any better?
Yes, actually
as a matter of fact, are you really? Okay.
Yes, I think it is, because the source of truth for the YAML is the Q file. So that way, you're either going to have a great YAML file or you're going to have a busted YAML file. But the truth is the Q file.
That's where I disagree. The truth is YAML of the desired state. Q is how we get to it.
Right, but if you're generating the YAML file, and I agree with you on that point, the desired state is the YAML file. We both agree on that point. But my issue is, if you have decided that the Q process is generating that desired state YAML file, then Q is the actual only file and the only process that matters.
Yes, but that's easy problem to solve, right? If I want to prevent somebody from doing that, I can just keep it in a different repo, right? And not give that person access, if that's the goal. Let me change it, but I think it's going to be very similar, right? What happens if somebody goes to my cluster and modifies manually the pod? Pod is the real actual state. Deployment is not. Deployment creates replica set, which creates pods. They're the way how to get to the pod. Pod is the one that matters, right? Now, what happens if you change the pod? Well, it won't stay changed for long. That's what happens, right? Because the deployment will say, oh, no, that's not a pod I'm managing. Either I don't know what that pod is and I'm going to ignore it, or more likely, depending on whether you change some specific labels, more likely I'm going to undo your changes. Same thing would happen with my Q files, right, and YAML. I'm making assumption now that all that conversion from Q to YAML is done through pipelines, right? And if you make changes to that YAML, which is in the same repository as Q, and you push it, pipeline would undo those changes before they even reach anywhere, before they're applied, right? Or if it's in a different repository, then you would be luckier because those changes would be applied until the next time I change anything in Q, which is probably not long afterwards. Oh, sorry, not in Q, but in a repository where those Q files are stored, right? So it's a short-term change at best. I mean, at best for that person who wanted to do that. I believe in automation. I believe that's why I mentioned the example of deployments of pipelines and stuff like that, right? We don't change files and apply them manually, hopefully, anymore, unless we're practicing something. So in that case, I think it's not a big deal.
I still think it's a big deal, but we'll move on from that because, again, if a file is being generated, it should always be generated.
Yes. Yeah, so I agree 100%. Like that YAML file that I'm talking about, that's supposed to be untouchable. I'm just talking about some malicious person or some person who doesn't know better, and I was too lazy to protect it from changes, right?
Okay. So you were just being lazy. I'm fine with that.
Yeah, those files that those YAML that I generate with Q, they are stored in Git because I want to keep them, but they're not supposed to be touched.
So let's go back to the declarative side for just a minute. And using the Terraform syntax, I'm using Terraform just as the high level thing.
Sure.
Yes, it's declarative, but no, it's not declarative.
Mostly declarative.
It's mostly declarative.
It's more declarative than not. The only declarative formats are, there are others that I cannot remember now, but YAML is declarative, XML is declarative, JSON is declarative. I might have missed one or two from the past, right? But TOML might be declarative. I'm not sure. Anyways, Q is not declarative, and Terraform is not declarative. When I say in this concept, it's not 100% declarative. I had a small argument with the team that created GitOps manifest or whatever. There are 4 rules for to be in GitOps, no matter whether we agree or no. And one of them is declarative format. And I complained about it because actually I didn't complain about that. I complained about the fact that everybody assumes that Helm is declarative. And I'm saying it's not. Right? It's not declarative. I'm not saying it's bad, but it's not declarative. The moment you put a loop or an if-else statement or something like that, it's not declarative anymore. It might be more declarative than others. Just as Go is, if you go to Java, for example, Java has declarative elements in it, right? You can define, correct me now with the syntax, right? You can define a const or whatever is the syntax, and there you go. That specific instruction is declarative. It's immutable. It's unchangeable in that certain version, right? I don't know how we got here, but Helm is not declarative, or whichever. Terraform HCL is not 100% declarative. That's for sure. It's declarative-ish.
So which is better or worse? Full declarative, so YAML, TOML, whatever. Full programming, Go, JavaScript, whatever, or this, what feels really dangerous in the middle. Okay, let's use AWS. CloudFormation. Mm-hmm. CloudFormation to me is completely declarative.
Yes, it is.
I never want to write that ever in my life.
Yes, but that's what AWS API accepts, right? Most of the APIs are declarative. So you're expected to give a declarative state to an API, and then things will happen. It's not your problem anymore, right? The question that you're posing, my interpretation of it is, okay, so do we write directly in that format that the API expects, like in Kubernetes YAML, CloudFormation case of AWS and what's not? Or do we use the tool that will help us generate that format? And if we do that, do we store that state before it's applied to the API, or just kind of have it be lost in ether, right? In most cases, unless it's something very, very simple, you cannot be writing directly a declarative format. You cannot do that, right? You're going to get lost easily and you will not be able to accomplish. It's possible, but it's not a good idea, right? Simple example would be, when I work with AWS, I create a subnet in each zone that I'm using, right? 3-4 zones in a region. And those subnets are mostly the same. I change the name, I might change CIDR block or something like that, and that's it, right? Everything else is the same. I can have it 3 times repeated, or I can have a loop. Loop is easier. Loop is better. Too much repetition. And this is an example that you could somehow do in declarative format. There are many other cases where you cannot. I mean, you always can, but it's going to be even much more complicated than that. So you cannot write declarative format directly. What I'm asking is whether you should store it somewhere or just create it temporarily so that it's applied to the API and then delete it. So here's my question. Should you, if declarative format is unavoidable, should you delete it? That's my question.
That's a great question, because if you delete it and you have a new version of the tool that's generating that declarative definition, that changes how it's defining the declarative definition in your host.
Here's an example. When you use Helm, most people, I feel, don't know, but Helm is creating YAML and then deleting it. And when I say deleting it, I'm not really serious. It's not really deleting it. It's all in memory, right? But create in memory and then delete it. So that's my question. Should you let it delete that YAML that it sent to API? Because trust me, Helm cannot send a Helm chart to Kubernetes API. Kubernetes doesn't understand what that is.
Okay, I'll say it. You shouldn't be using Helm, but that's a different conversation.
That's a different conversation, exactly. But I use it because it's easier probably for people to understand that than talking about Terraform that converts into API format specific to API of the provider that you're currently using, right? It's more than, it's not one format, right? But they all do the same thing. They all convert their stuff into a declarative format that is accepted by the API, and then they remove it from memory. And all I'm saying, just don't remove it. Keep it.
That way you know what the state should be, but you're still stuck with the should be, though, right? Because it may not actually, I know you like using the word converge, but that doesn't help me any. It's like, did it actually apply successfully?
To me, it's just simplification to, we have a problem and this is what's happening, but what is supposed to be there? And I think that I would die on that one, that it's easier for anybody to understand what something is supposed to be by looking at declarative format, let's say YAML, than going through Go code or JavaScript code or Java code and, trying to go through all the paths to assemble mental image of what that something is. Anybody who ever debug an application will understand the problem of trying to figure out what's going on and what's the expected outcome.
So, unsurprisingly, we've deviated from what we were talking about. What is infrastructure as code and DevOps? It's what you should be doing, right? In today's world, in 2024, if all you're doing is pointing and clicking, not when you're first starting out, right? That's legitimate. You're trying to figure it out. That's all good. I'm talking about you've been an AWS shop for 7 years, and you're still going in and pointing and clicking to do everything.
Please let me know what company you're working in so that I put it on my blacklist never to apply for a job.
Let's go ahead and pull this back even a little bit further. And this is what you were talking about when you were talking about GitOps a little bit earlier. I mean, you were sort of pushing on one thing, but stepping back and looking at it. In a perfect world, yes, I still have access to go somewhere and look at a UI.
Yes.
But I should not be able to have the capabilities to make changes there unless I am in a break glass scenario.
Yeah. If it's not break glass scenario, I'm a terminal type of person. Everybody knows I love terminals, right? But terminals are not good for everything. Terminals are good to execute stuff. Editors are good to edit stuff, like Visual Studio Code, right? And consoles, which you're referring to, they're great for observing things, right? I would never consider having a terminal-like solution or that would replace Grafana. It kind of sounds silly. So for observing the state of something, the actual state of something, or even the the desired state, we need graphical user interfaces. And they're great at that. Just remove that button that says delete this thing or create that thing.
And more importantly, get rid of the update. So if you can get rid of all the CRUD and it's used as a dashboard, and again, you do have the ability, if you're one of the blessed 5 people in the organization, there better be sort of like nuclear codes. There better be 2 people on either side of the room with separate keys. And those keys have to be turned at the same time in order to move into the next level.
When you get to the point that you manage things, I'm going to say the Hollywood word the right way, right? You keep stuff in Git. You have processes that are converging those states from whichever format to whatever the API expects and so on. When you get to that point, break glass scenario is actually relatively hard because you cannot just access your AWS account and change things because your changes will be undone with the correct way to do things. So break glass scenario means, okay, I'm going to go to my AWS account or Google Kubernetes cluster or wherever I'm breaking glass. But before I do any of those things, I need to stop the processes that I'm normally running. Stop Argo CD from synchronizing. Stop Terraform from doing whatever it's doing. Stop Crossplane from doing whatever it's doing, and so on and so forth, right? You need to stop the factory and then go to manual labor. You cannot do manual operations while factory is still running. And that's why you need those keys. You cannot take it lightly. It's not kind of, hey, Joe is going to fix it. He's not. I mean, he might for a minute.
But the key point there is, and you're sort of using the Toyota way, if you will. Somebody pulled the and-on cord. The line stopped.
Exactly.
Like fully stopped.
Exactly.
And then how long is it going to take me to get back? Because even if we fix the thing right then, guess what? The line is going to start up again. And as you were saying, if I turn everything back up, whatever I did manually is going to be gone.
If I would continue using the Toyota example, without that cord that says stop everything, that would mean you jump on a, how do you call it, the lane that moves,
You're moving on the carriage line.
Carriage line, exactly. And then you're moving, you step on it and you go with it together, right? And you're fixing it while it's in motion and while things are happening. You're not going to live long in Toyota if you try to do that.
Yeah, that would be dangerous.
Exactly.
You're taking your life at risk. You're putting a lot of other people's lives at risk.
Exactly. And the end outcome is not going to be what you expected it to be. I can guarantee you that. Apart from you being dead.
Yeah, but you got the work done before you went off and died on the line.
Yeah, but you're trying to unscrew a screw while machine is screwing it in. Right? That's what you're trying to do. There is a machine, a robot, screwing a screw, putting it in while you're trying to unscrew it. It's you against machine.
Machine will win.
Exactly.
Unless you shut the machine down.
That's that cord, right? You need to shut down your processes if you want to do any break glass operation.
But even if you do break glass, here's the problem. You can't turn the machine back up until you've put what you broke glass for into the machine.
Exactly. It's same like Toyota. I'm pretty sure when they shut it down, there is something to be done, something that was not working well in the current process. And you might fix the cars that are currently ongoing and that are faulty because of the machine, but you ultimately need to fix the machine. Otherwise, you turn it back on and the same thing happens.
So how are you handling your infrastructure as code in your DevOps world? Head over to the Slack workspace, check out the podcast channel, and leave us your comments there.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.